Hey guys, it's Andrew here again, and in the last video we took a look at breaking down some given IP address. So in this case we got 192.168.42.0 in this /24 network. And last time we looked at, how could we break that up into smaller pieces? And we borrowed a bit here, and every time we borrowed a bit, we shrunk the size of each network, but we increased the number of networks, right? We doubled the amount of networks that we had. In this case, we're given one network of 256 total hosts. And then by borrowing a bit here, right there, we went down to a /25, and we now had two networks of 128 hosts. And then we went down again and we had four networks of 64 hosts. And just by me saying that, we can start to see the pattern here, but based on that pattern, we can develop something called the magic number. And this is going to be a way for us to easily determine how many devices can exist, or how many hosts, maximum hosts that can exist per network, minus the network minus the broadcast. The maximum hosts per network, and then based on that value, and whether, in this case /24, we can take that value, whatever it is, and divide by the given bit position here by the 256 and determine how many subnetworks of that value we will have. All right. So looking forward here, let's say we want to, we want to take this /24 and we want to divide it up into 4 even pieces, or 4 networks of at least 62 usable hosts, or 64. Now, just looking at this, we can see that we would need to borrow at least 2 bits, right? We borrow this guy here and this one here. All right. So let me just clean this up here, and we will borrow these. All right. We're going to borrow these guys, give them to the network. All right, a 1 and a 1. All right. So the magic number in this case is the point at which, on our binary scale here, we switch from network bits to host bits. And this last network bit, wherever the network bit falls, becomes my magic number. So 64 in this case becomes my magic number. All right. And what this magic number is going to tell us is going to give us 2 things. First, since it's a /24 network, all right, since it's a /24, all right, it's a /24, we know this is 2 to the 8th, or 256 total hosts. And if we take that 64, this magic number, and we divide by it, we find out that we're going to have 4 networks of 64. All right, and it also tells us how many values we have per network. Okay, so now we can actually figure out each of the different ranges that exist, right? Because remember, looking into NFLB, depending on the size of our network, an IP address in a /26 in this case, again, we had 24 plus 2. So again, this also tells us these 2 plus the 24. This is going to be a /26 network. Okay. So based on these values, we can figure out where each and every network begins and ends, right? So we know that each of these is going to be 192, right? 192.168.42. something, right? In this case, we're starting with a value of 0. So my first network is going to start at 0, and it's going to be a /26. All right, but because it's 64, we're going to go up 64 values. So I could easily determine here that my next network is 192.168.42.64. All right, /26. And then let's see here, we have 192.168.42.128/64. Oh, not /64, my bad. Oh, that's IPv6. Getting a little ahead of myself. /26, my bad, guys. really want to get to IPv6, huh? /26, okay. And 192.168.42.192/26, okay. Now, at this point, you could use, given this value and the network address, you found the network, you could find the first, last, and broadcast for each of these networks, right? And this would just be as simple as going through the network first, last, broadcast, doing the ANDing process, or actually you don't even need to do the ANDing process, just flipping the host bits. So you have 6 host bits, so flipping them, and then based on this new network address value, flipping those host bits, flipping these, and you would be able to find the broadcast address. Or we can make this just a little bit simpler. If this is the beginning of the network and this is the beginning of the next network, 64, then 63 would be the broadcast for this network right here, okay? So 0 to 63, 0 is the network, 63 is the broadcast. 64 is the next network. So if 64 is the next network, and then after this, in this network, and 128 is the next one after that, you can bet that 127 is the broadcast for this network right here. All right, so we can start to play with the numbers, so you don't have to go through the whole ANDing process and the network first, last, broadcast. And then again, once again, it's just +1 the network address and -1 the broadcast address for the first and the last, and you've got your range of addresses. All right, so using this magic number really speeds up this this subnetting process. So we are going to start looking at taking this this magic number and moving into something called VLSM, which is variable length subnet masks. So with variable length subnet masks, we're going to have a bunch of different networks of different sizes moving forward, and we're going to have to go in and we're going to have to figure out how do we take this /24 network and split it up into different sizes to make sure all of our networks fit on inside of our given /24 or given /25 or whatever we're given. And we're going to do that as quickly as possible using this magic number technique. So I will see you guys in the next video with VLSM.